Okay, this is the video solution for the midterm one or midterm of the CAE course, and this is for section 53. Okay, when you look at this problem, notice that there is a part that's given here, and it says that the inside of this thing, inside of this hole, is clamped. And by the way, you're asked to do local mesh definement around the edges. Just show me that you can do it. Okay. Now, the other thing is that the entire structure is subjected to temperature rise of 400 degrees Fahrenheit. Okay. So remember, if the room temperature is considered to be 68 degrees in that environment branch of the tree, the temperature that you add is going to be 68 plus 400. If the environment temperature is set as zero, you set it as zero, then the temperature of the part is going to be zero plus 400, which is 400 degrees Fahrenheit. Okay, now you're asked to use the most appropriate element. I'm sure that probably 90, I don't know, 9% of you guys will do this thing as a solid element. Okay, then maybe the 1% who decide to do something different and use shells, and as long as you do it properly, you will get the full mark. As long as you do it correctly. Okay. The other thing is that to use all planes of symmetry. Okay, all planes of symmetry. When you look at this problem, you look at the restraint, the geometry, and the temperature rise, which is the load, you see that there are two planes of symmetry. One is you take it up from top to bottom, and then you cut it along the length of this thing. Okay, so the choice is yours. How you want to do that? You can make actually 1/4 of the model, or you can make the whole model and then use the split to cut it. I'll make the whole model, and then I will split it. It really doesn't matter to us. Okay. Uh, Good. So let's start with a part file. And immediately I'm going to save this thing. Let's go to part design, by the way, because you're making a solid object. So on that plane, I will sketch something that resembles the thing that you saw in that figure. So I'll do something like this. I'll clean it up later. We come here like that. We come here, okay, like so. This, and I will clean it up. We'll clean it up. Okay. So left line, control right line, control middle axis. You make it symmetric. Okay. Uh, let's make this thing parallel to that. Make it horizontal, actually. We can do that. Horizontal. Okay. Now, let's see now. This line, control that line, control middle axis. We're going to make it again symmetric. And there are different ways of doing this problem, obviously. Okay, that being the case, okay, this guy, control that. We're going to make them tangent to each other. Okay, I think now we have it all sorted out. So let's see now. If I move this thing, it's going to move symmetrically. Move this thing symmetrically. Very good. And then we have a circle in the middle. So let's make a full circle in the middle. And now we're going to put dimensions. Okay, so dimensions. Let's see now. This bottom is 6 inches. Right now it is 12, so let me make it 6. Okay, this is 1 inch. Okay, and that is 2. That's also 1 inch. 1 inch. Okay, this radius is 0.5 inches. Diameter 1. All right. Now let's see. Now this angle is 120 degrees. The angle from here to there is 120. Okay. And let's move that circle down so that it is, yeah. So there are different ways of fixing this thing. You can do it like that. You want to make these two concentric. That's what they are. It looks like they're concentric based on the drawing. Yep. So we're going to make this thing this curve, control that curve, and we're going to make them concentric. It looks like they were already concentric. So it's just a matter of putting a radius here, and that radius is 1 inch. I'm pretty sure this is the model that you have. Okay. Yep. All right. So exit, and we're going to pad it in both directions with mirror extent. Well, this is ridiculous. Because I'm going to be cutting it in just a minute, and that is 0.5 in each direction, which is total of 1 as the width of the sky. Okay, that is your part. Why don't we save this thing? So file, save management, save as, desktop, new folder, and I'm going to call this thing lab midterm lab 53, midterm lab 53, and it's going to be problem 1. Problem 1. Okay, I'm going to go in there, say okay, and close. All right, we are told that this is made out of steel with default material properties. So apply material here. There's the apply material, metal, steel on the part. Say okay, save it, and let's do a cut here. We're going to split it this way, and it doesn't matter which side we pick. I'll pick the other side. Okay, doesn't matter. And then again, split it with the middle plane, and again, it doesn't matter. So this is the model that you have to analyze. Okay, save it. Yeah, and then you go to generative structure analysis. The model is saved. The model is meshed. Okay. Now we are told to have a fine mesh around this. Okay. Yeah. Have a fine mesh around this, and you know how to do that. You go to the tool manager, the second toolbar on the left. You go to local mesh size, and you're going to select this. And what it does, it puts a finer mesh in this area. If you want to make it finer, that's fine. The actual numbers don't matter to us. We just want to make sure that you can do it. That's all. There. Okay. And if you want to see your mesh, you can see right click mesh visualization. Yeah. So you can see that over here, the element size is bigger than that. As a matter of fact, this is fine, but I wanted to convince you that actually we did something. I'm going to make this thing 0.05. And now look at the activate the mesh. It's going to be a lot finer in that area. We really didn't say how much. We just want to make sure you can do that. You see this right there. Generally speaking, people put fillets here for manufacturing purposes and things like that, but that's okay. We don't want it. You're not asked to do it. Don't do it. Right click, deactivate. Let's move on with the rest of the problem. You're told that this surface, this inside hole is clamped. So let's get a clamp here. There's an inside hole. Okay, it is clamped. You see that? Okay, and then there are slider surfaces on places where we have symmetry. We cut it there. This is surface slider, and we turn it around. Oh, don't forget the stop piece. No part marks. No part marks. Don't miss out anything. And the back face. Okay, So let's save the analysis, file, save management, analysis, save as in the same folder, same default name, analysis one. Of course, what you submit is going to be your student ID number, your last name, etc. Okay, that's good. Now, we are told that this entire thing is subjected to temperature rise. Notice that if I go to load right there, if I go to load and click on this, which is temperature field, as soon as I do that, you get an environment branch here. Okay, so this environment branch, you set the room temperature. Okay, so if I say, if I select that object, over here, I have to put 400 plus the room temperature. Okay. Now, let me cancel that thing for a second. Yeah. Sorry. Let's do that one more time. This and say okay. Let's go find out what our room temperature was. So this is 68. So 400 plus this is going to be 468. Okay. So what the temperature should be is 468, and there's a 0.01, whatever. So that's going to be 468 dash point oh, I don't know, 0.01. That's really not critical. Good. Save it and then run it. Nothing exotic is going to happen here. This basically deforms because this is fixed there. If it's not free expansion, if it was a free expansion, if this was floating in the space, without anything being clamped and you raise the temperature, the stress is going to be zero, but of course there's going to be strain and become flatter. But here, because this is clamped, there's going to be some stress distribution around that hole. So look at the deformation. There we are. It is almost free expansion, not quite because these are fixed. All right. If you look at the stress distribution, yeah, it's like that. Most of it is around the clamped area. Yeah. Just like what we expected. Now, if you want to, I didn't ask for it, but if you want to look at the stress distribution in this area, so here's what I'm going to do. Let me cancel that. Okay, let me deactivate this. We didn't ask you to do this. However, I don't mind showing you. Deactivate that. Let me make a group here. This is a gigantic group, so I'm going to resize it first, and I'm going to move it. I'm going to move it to this location. And I'll make it a little bit bigger here so that it really covers uh, that notch right there. And then we can say, okay, show me the stress, but don't show me everything. Just show me the stuff in the box group. And you can hide it and reveal the stress distribution here. That was not asked for. So let's save this and stop the recording.